rod be hinged here. This is string. Okay, fine. So this will be, so let there be a magnetic field here into the plane. So B bar. So this will be the, let the current I flow like this. So some battery is connected. Let's not bother that one. So this is having a mass M. So what will be the angle theta and tension in this string? Find the rod AB is in equilibrium. Rod AB is in equilibrium. Find the tension in the string. So what are the forces that will be acting? Weight mg. Any BL force should act. B bar current. So how that force? Now there is a uniform magnetic field. So the BL force will act perpendicular to the rod. BL force should act perpendicular to the rod. Length of the rod, let it be AB equal to L, and mass of the rod be M. The string will be taut, so the tension will act here. Will there be any reaction at the hinge? Yes, there will be reaction forces will be acting at the hinge. So what are the reaction forces here? Ry, and let this be Rx. Can we equate forces directly? Tension means, sir, a component of BL. No, the reaction forces will come. No, that's why we are taking help of the torque. So net torque about it, as it as it is in equilibrium, net torque about A should be 0. So therefore, mg L by 2 cos theta. Net torque about A due to weight, L by 2 cos theta, due to BIL. BIL into L by 2. This will be anti-clockwise. Torque due to tension, T into L sine theta. All set equal to 0. Look at the arrows. About point A, mg will set up clockwise torque. About point A, you can see BIL into L by 2 and anti-torque, anti-clockwise. Tension. So this distance will be how much? This is L cos theta. Sorry, L sin theta. So perpendicular distance, L sin theta. L sin theta into T. So equate this. So mg L by 2 you can take common. So this will be mg cos theta negative BIL plus 2t sin theta equal to 0. Solving this, we'll get expression for the tension. So the tension 2t sin theta should be equal to mg cos theta minus BIL. This will be the tension. Can we calculate now reactions? What about the reaction forces? Equate forces along x and y on the rod. And calculate Rx. If you get Rx negative, you just said, so what is this RYRX? Forces acting on the rod, not on the inch. On the inch should be opposite to this. I think you know this. Whenever we say that rod suspended, no, what we show reactions are on the rod. On the inch should be opposite to RYRX, what I indicated. Fine, so this will be reaction forces we can calculate here. T, this will be theta BIL sin theta minus Rx equal to 0. I'm resolving the component of BIL. So the component of BIL along x-axis. So this should be the theta, no? So BIL sin theta will act along x-axis here. So we know value of tension. Substitute here, you'll get expression for Rx. Similarly, what about Ry? Ry should be equal to Ry minus mg minus BIL cos theta. What are Rx and Ry? They are reactions at the inch. See, all what I introduced are the fundamentals regarding ampere force. This is the first time you are coming across an ampere force. So what is the ampere force? I just took the help of that spring one. I just took help of the spring one. Here I'm showing the time period also. Time period of means the BIL force, can it, is it a conservative force? As if it were non-conservative, okay, I would have not applied here. No, it's a conservative force. What is the nature of it? It's a conservative in nature. That's the thing. Next again, can it set up a torque? Yes. Can it accelerate a body? Yes. Can it retard a body? Yes. So it's all the things what a force used to do in the mechanics. No, the similar type of application problems what you can come across. I think this is what they focus more in advance. Two types of problems, and just based on electromagnetism, some questions will be there. Next application question comes, means ampere force along with the tension, along with the friction, along with the weight, along with the spring force. You have to explore. There will be no safer questions. So mixed concepts are very important. Yeah. Tomorrow we'll go for some application problems. Let me introduce to dipole moment, magnetic dipole moment. Meanwhile, you can see this. I'll have water.
Sir, BIL cos theta is acting upwards, no sir?
Yes, BIL cos theta should come.
Okay, now we'll take the magnetic dipole moment. Now, look at the name of the chapter, electromagnetism. No, so what we are saying that a current carrying wire will behave similar to like a magnet. And whenever the word magnet comes, what will first thing will flash? South pole, north pole, no? Because this is very important to study the magnetic property.